Today, a brief introduction to animation using GlowScript vPython. Basically, it's a good idea to organize your program into three different areas. The first area is to create the objects that are going to move. The second area or zone is to set up time. And the third area is a computational device known as a loop, a set of instructions that runs over and over again until some condition is met to break the loop. Today what we're going to do is animate a ball rolling around on a circle. So it's probably a good idea to draw a little picture of what you hope your animation to do. So what I'd like to do is create a sphere somewhere along the x-axis, and then let that sphere roll along in a circle in 2 dimensions. And it'd be really nice if I could get that ball to draw out a nice circle as it moves around. So what I know I have to do is create a sphere and give it a variable name. We'll just call ball for now. And set that sphere up with attributes. The most important is the initial position of the sphere, which is a vector. And I want that sphere to start out some distance away from the origin along the x-axis. We'll set it at 1 so that the ball will roll around on a circle of radius 1. And we'll give it a size. And color. To start the timeout, we probably want to create a time variable, calling it t is fine or calling it time is fine. T is a little bit easier, but there is no built-in time inside of vPython, except for one time animation command that I'll tell you about in Zone 3. So I'll start at time t equals 0. The other variable you need to define is some sort of time step, right? Computers can only work in finite steps, unlike real time that happens at least apparently continuously. We're going to have to let time go forwards in small steps, and I'll set that equal to ½ a second. For the loop, I'm going to use a construct called a while loop. And I'm going to set it up so that the loop will continue to operate until time reaches a certain amount of seconds. Okay, now inside the while loop, sorry, there should be a colon there, and then I'll get an automatic increment for the instructions inside the while loop. But what I need to do inside that loop is update the position of the object that I want to animate. And since we're in 2 dimensions, I'm going to update the x position and the y position of my ball. And the way I'll define those inside of the loop is they're going to be basically functions of time set up for a circle. So I've got a radius times the cosine of time, and the y position correspondingly is going to be the sine of time. Now, the ball has so far not been involved in this, and so I'm going to take these recomputed coordinates and make sure that the ball gets repositioned there. And to do that, all I need to do is pull out the position attribute of the ball and update it. I could correspondingly update its radius and its color, but there's no reason to do that. It's really the position that's going to be animated. So position is a vector with the recomputed coordinates in x and y. Z stays the same. And the last command that I want to do is update time by incrementing t. So I do that by adding the time step to time. Okay, let me run this. And sadly, the ball goes nowhere. And the reason why is that I've left out a very important internal command that you wouldn't know about unless someone told you. And it's a command called rate, R-A-T-E. And what that command does is it tells the instructions within that loop to run at a certain rate. And without that command, the mathematics happen so quickly that poor VPython cannot redraw the ball quickly enough. So we're going to need to control the drawing with this rate command. It's not controlling the math, it's controlling the drawing and the redrawing of that ball. And what I usually put in for my rate is the inverse of my time step. So if I've got a very small time step, the drawing happens quickly. A large time step means that the drawing can happen fairly slowly. So let's run the program now. And you can see that the ball is taking some jerky steps. And what's hard to see in 2 dimensions, now this wouldn't be so important in 1-dimensional motion, but in 2 dimensions it's probably good to have the ball leave some sort of trail behind so that you can see the path it took. And the way to do that, there's another attribute you can give the ball, something in VPython called make_trail. It's usually set up to be false for an object unless you tell it to be true. So I'm going to set make_trail equal true for my ball. And notice now what happens when the ball rolls. It leaves behind a nice yellow trail. So here's your challenge. Hopefully you've been recreating this program as we went along, but your challenge is to try to make this circular path smoother.